Hey, welcome back, and now we're going to go on further, and now we're going to discuss what even and odd functions look like when it comes to trigonometric functions. Now, you may have remembered studying this if you took algebra, college algebra, intermediate algebra, where we cover even and odd functions. So just to recall, an even function would be a function that looks like this. For example, y equals x squared. It's symmetric about the y-axis. So what does it mean to be even? It means that if I replace x with the opposite value of x, right? So if I go from positive and I plug in a negative value of x, guess what? The y values are the same. The y values don't change. So in other words, if I plug in the opposite value of x, I get the same function back out, okay? So that's what we call an even function, and this is how we represent it algebraically. So if we plug in the opposite value of x, if we plug in the opposite value of x and we get the same function back out, then it's an even function. Now, with odd functions, we have something like this, okay? Where we have, for example, x cubed, right? Y equals x cubed, which has this kind of shape to it. Now, this is an odd function, and odd functions are what we call symmetric about the origin, or with respect to the origin. So that means I can rotate this 180 degrees in either direction, and I'm going to get the exact same function, the exact same graph out of it. And so if you look here, if I just rotate this like a pin 180 degrees, I'm going to end up getting right back to where I started, or it's going to look exactly the same. Sorry. That's what we call an odd function. And so algebraically, we would represent this way. It means that if I put in the opposite value of x, so let's say I'm over here, and I have a point over here. If I put in the opposite value of x, I'm going to get something that's on the other side that's going to be flipped down over here. So what happens is I get the negative value of y, right? So if I plug in the positive value of x, in this case, I'm going to get the negative value of y. If I plug in a negative value of x, which then is down here, I get a positive value of y. Okay? So that's how we show algebraically that a function is odd. Okay? Now, how does that work with trigonometric functions? Well, it looks like, it turns out, I should say, that we have something similar with trig functions. So if you use the unit circle here, then we can see that, hey, there are certain functions that if I plug in an opposite value of x, right? Or if I plug in the opposite value of y, then I'm going to get the exact same thing out. Or I might get the opposite, right? For example, if I'm talking about sine, there might be if I put in the opposite value of x into sine, do I get sine? Do I get the opposite value of sine, or do I get neither? Okay? And so we're going to apply the same thinking to trigonometric functions, okay? And so we'll look at that next.